Hello everyone, I'm Vishnu Vardhan, currently pursuing artificial intelligence and data science in South Engineering College. I have to explain my final year project. My project name is Vehicle Resale Value Prediction and Customer Centric Vehicle Recommendation System. Now I am explaining by slide about my project. This is the agenda for my project: introduction, statement of the problem, scope of the project, and its methodology, outputs, test cases, conclusion, future work, and its references. The basic introduction of my project is I have to predict the vehicle resale value for the vehicle. The prediction of vehicle resale value is a crucial factor in the automotive industry, affecting buyers, sellers, and dealerships. Traditional methods rely on manual assessments and historical sales data, which can be inconsistent and inefficient. Majorly, I used random forest and gradient boosting and XG boosting algorithms for predicting the resale values based on customer recommendations by using the vehicle age, mileage, engine power, and fuel type. And the major statement of the problem is that traditional approach may give the causes for the vehicle resale value prediction, and I'm using to predicting the resale values based on the historical sales data, which is useful for both buyers and sellers also. This is the statement of my project. And while coming to the scope of my project, these are the main scope of my project: to develop a machine learning model to accurately predict car resale value prediction based on various factors such as brand, model, age, mileage, and market trends. These are the target audience or car dealerships, automotive sellers, and buyers, and then financial institutions also. And then these are the another scope of my projects. I include the inclusions and exclusions. Inclusions is nothing but data collection and future engineering, and what are the algorithms I was used in this project. And the exclusions, um, whatever I didn't include that in my project, like specific market conditions. There are no real-time pricing updates. And then it is one of the scope of my project also. By using this type of vehicle recommendations, I done my pre-processing data. And then the methodology for predicting car resale value prediction using machine learning is data collection. Data collection is nothing but I have to collect about the vehicle details and all for pre-processing step. And then before pre-processing step, data collection is a crucial role. And then for the pre-processing step, handle the missing values and fill in the categorical data and perform the future engineering based on these types: car age, mileage, and this. And then I normalize and encode the features by using hot and label encoding. And I perform the exploratory data analysis, which is nothing but to perform the correlational analysis and identify the future relationships to visualize the data distributions and detecting outliers. Detecting outliers is nothing but which the data points are not required for predicting the result values, and to visualize the data. And I select the models like random forest, gradient boosting, and exit boosting, and using the performance metrics like mean square error, RMS, MA, and the R square to compare the models, because I have to know that which model is best for predicting the result values. And I perform the hyper tuning. And then model evaluation is the crucial part for predicting the accuracy. And I done the future importance and interpretation. uh, and deployment and prediction is the final step for that one. And validation and continuous employment, they periodically retrain the model with updated data for the better accuracy. And this is the architecture diagram for my project. Nothing but we have to collect the data, perform the data pre-processing, exploratory data analysis, model selection, hyper tuning, model evaluation, This is one data flow diagram, and this is the full data flow diagram, and this it is the architecture diagram for this one also. And this is the design use case diagram for my project. This is the user and this is the system, how I collect the data, how I pre-process the data. This is the data scientist. He can perform the exploratory and select the model, hypertuning models, and then at last he make the prediction for resale value prediction. In this pie chart I explain about how much of a percentage I have used for in my project, like for data collection I use the 25%, and model evaluation I use the 20%, and hyper parameter tuning I use the 15%. This like I explain which what the percentage I have used for my model. And this is the basic UML diagram from my car result value prediction. And this is the sequence diagram, how I performed result value prediction by step data processing, exploratory data analysis, model evaluation, tuning model. After I predict that result value prediction, these are the another sequence diagram for my model. This is also a sequence diagram. And last I explain about what are the algorithms I was used in my predictive model. First one is random forest regressor and gradient boosting regressor and XG boosting regressor. And I explain about the random forest regressor. Random forest is an ensemble method that combines the multiple decisions trees to enhance the predicting accuracy. It means it is random forest regressor is coming from the decision trees. While coming to the decision trees, it gives the inaccurate data and it cannot predict the long data and complex data. So multiple decision trees combines, we form a random forest regressor for predicting the result value prediction. This is the main purpose I was used for random forest. Then what is the use of gradient boosting regression means, when we have to remove the data, unnecessary data, we have to use the gradient boosting, because it will remove the what is the initial data, inaccurate data. You have to remove that data only, it will remove another data, it will save. And the major purpose is minimal loss of data. This is one of the main usage of this gradient boosting. Another disadvantage is very speed is very less and it gives a less accuracy. For to rectify that one, I use the XGBoost algorithm. It's nothing but extreme gradient boosting. It improves the speed and gives the best accuracy for my result value prediction. And this is the hardware selections and the software selections for my project, processor, RAM, storage, and GPU. And then this is the software selection. And then this is a project implementation. What are the packages I was used, like Pandas, NumPy, Skitlan, XGBoost algorithms, Matplotlib, Seaborn for visualizations. And then this is the functionality for my project, where I have to collect the data and how pre-processing data can be done, and highlight and training and splitting of the data. At last, how can I get the result value prediction? This is the important code segments of my result value prediction. This is the pandas which I use it to read the data. And then this step is nothing but pre-processing step to remove the null values and unwanted data, repeated data, like that. And this model training, XGBoost regressor and random forest regressor I used in this code. And these are the metrics I was used, MSC and R2 score, and how I perform the data for training and testing. And this is the splitting of the data into training and testing sets. And then for random forest to training model, for gradient boosting training model, and then for XGBoost training model. This is the evaluation of my code, like by using the statement from sklearn of metrics import MSC and R2 square. For predicting Y predictions, I use these conditions and these statements. And after writing these codes and I predict the resale value prediction. What are the best cars and what are the worst cars based on this quantile 0.75, and then based on user conditions I write this code. What is the name and engine and distance traveled, what is the budget, and this budget is specified because all middle class persons have that budget by buying the car. So I include this one also for getting the user recommendations. um, this is the final. After writing the code, what is the output I was getting? This is the training and testing data and algorithms random CV, which is the best algorithms gradient boosting regressor, because it minimal loss of the data and the speed also very high. This is the random forest and gradient boosting XA boost RMSE scores and R square values. Gradient boosting has the R square values which is the highest value, and then XA boost have the 4.28 value for RMSE. This is the correlation heat map for my project, and these are the visualizations for resale value prediction. And these are the KDE plot for my power and mileage. It will differentiate what is density and then value for my car. Here it tells about which algorithm has some more RMSE score, XGBoost algorithm, and here it denotes what is the best cost and worst cost for it will send to that one. And it is for the user recommendations like after entering the brand value and the model, mileage in kilometers, manufacturing year, original price, resale value, it will predicted depreciation, it will give the values and more like this. And these are the test cases for my project. After getting these are the results, I will get the car resale value prediction for each car, and it gets accuracy and based on your user recommendations, and it gives the available cars and which are best and which are worst. And this is the final conclusion. This project on vehicle resale value prediction and customer centric vehicle recommendation systems addresses a critical need in automotive market where accurate pricing and tailored recommendations can significantly buy and seller experiences. And this is the future work. I want to add the market trends and key factors in the inflation rates and fuel prices, because every month and every year there is inflation in the market, increasing and decreasing the car rates and fuel rates based on market. I want to add these features also, and I want to add voice search and virtual assistance for my project. This is the future work for my project, and these are the basic references for my car resale value prediction. Thank you.